Now here's problem number 16, and it's a really cool problem. Min enters the numbers 1 through 81 into the cells of a 9 cross 9 grid in some order. I've already drawn a crude 9 cross 9 grid here to help us solve the problem. She calculates the product of the numbers in each row and column. What is the least number of rows and columns that could have a product divisible by 3? So once she places the numbers 1 through 81 into this grid, she calculates the product of each row, of each column, and then the problem is to find the least number of rows and columns that could have a product divisible by 3. Now, the key idea here is that for the product of any row or column to be divisible by 3, there must be some multiple of 3 in that row or column. So let's call any such row or column that has a product divisible by 3, or that has a multiple of 3 in it. Let's call any such row or column a bad row or column, because we don't want that. We want to minimize such rows and columns. So a bad row or column is any row or column which has a multiple of 3 in it. And we need to minimize the number of bad rows and columns. Now, the number of multiples of 3 from 1 to 81 is simply 81 divided by 3, which is 27. So the numbers 3, 6, 9, 12 up to 81, which is 27 numbers in total, are the offending numbers that make a row or column bad, and we have to place them in a way that gives us the minimum number of bad rows and columns. So one option, for example, could be that we place all those 27 multiples of 3 in, let's say, 3 columns like this. So in that case, we would get 3 bad columns, but we would also get 9 bad rows. So each of these 9 rows will be a bad row, and therefore we would get 3 plus 9 or 12 bad rows plus columns in total. So how do we minimize this number of bad rows and columns? Well, the trick is to realize that we have to place them in the most square way possible to minimize the bad number of rows and columns. So if, for example, we take 25 of these 27 numbers and place them like this. So we've placed 25 numbers like this. How many bad rows and columns do we get so far? So we have 1, 2, 3, 4, 5 bad rows, and then 6, 7, 8, 9, 10. A total of 10 bad rows and columns. And now we still have to place 2 more. So we could place those 2 more multiples of 3 perhaps here and here. So this would give us another, we've already counted the bad rows, but this would give us another bad column. So in total, we would get 10 plus this 1, a total of 11 bad rows and columns, and this is the minimum number of bad rows and columns that we can get. So the answer to this case, this problem is D11.